going to talk a little bit now about the speed and duplex settings in our Cisco switch ports. And while they can be hard-coded, Cisco switch ports are now set to automatically negotiate or auto-negotiate that port speed and duplex with their connected partner. And basically the port and the connected device have a quick conversation about the highest level of speed and whether each one can support full duplex or half duplex, and then they come to an agreement about the speed and duplex to be used when data is actually transmitted. Could go a little something like this. The switch port says, hey, you are connected to a 100 meg port, runs at full duplex, it's fast Ethernet, fantastic service, you're going to love it. And the host has to say, wait a minute, I'm running at full duplex too, but I only run at 10 meg, so they're going to have to come to an agreement on that speed, even though they agree on duplex. The results of the negotiation will not surprise you. The highest speed that is supported by both is going to be used. So that prevents one device or the other from being overwhelmed by data. If one end is an Ethernet connection and the other is gig Ethernet, an outlandish example I grant you, but the Ethernet connection, the Ethernet port would have a hard time keeping up with that. And of course, it wouldn't be able to keep up with a fast Ethernet port either. Now, when it comes to the duplex service, full is always going to be preferred over half. Full duplex being that ports can send and receive simultaneously, and they also avoid that CSMA CD process we talked about in an earlier video. Half duplex is where a port can send or receive at any given time, but it can't do each simultaneously, and it's going to have to go through CSMA CD. So that obviously is why we prefer full over half. Now, as far as auto negotiation goes, I'm going to give you a little bit of a history lesson, very brief, I promise you, and it has something to do with what you're seeing on the screen right now. Auto negotiation originally worked so badly that Cisco itself had a best practice of not using auto negotiation. Yeah, it really was that bad. It was in their own stuff, their own PDFs. And the thing is, that's stuck in some people's minds, and every once in a while, it's, oh, auto negotiation, that stinks. We don't want to use that. Let's hard code everything. The thing is, auto negotiation works so well now that it's actually the default setting on our Cisco switch ports. So if you read something older, 5, 10 years ago, or someone tells you, oh, auto negotiation is terrible, that might have been the case at one point. Actually, it was the case at one point. But today it's perfectly fine. Now, why do I have this on the board? Don't do this. I don't use stop signs real often, but this is something you don't want to do. The only time you really, the only time you really notice auto negotiation, it's like a boxing referee. The only time you notice the ref or an umpire in any sport really is when something is wrong. Well, that's the only time you're really going to notice auto negotiation is when this goes wrong. And what happens is if you have one end that is set for auto negotiation and one end of the connection that is not, that's where you end up with a problem. And it's a problem that can actually be pretty difficult to spot. Now, Cisco switches have a leg up in this situation that I just showed you because they can detect that connected device's speed without auto negotiation. And you're like, wow, okay, why do I even need auto negotiation? Well, the problem is Cisco switches can't detect the duplex of that connected host, and that's where trouble rides into town. Because if the Cisco switch detects a speed of 100 meg or less, and then cannot detect the device's duplex, then the switch sets its port to half duplex. And we end up with something that sounds kind of innocent. It's a duplex mismatch. It's like, well, hey, it's just a mismatch. How bad can that be? It can be really bad. In my estimation, using a bit of a literal reference here, in Inferno, the ninth circle of hell was the deepest circle, and duplex mismatches would be in the 10th circle if they were in that, because they're hard to spot because they don't make the link go down. They just make it really ineffective. I mean that so much. I said it twice, once on the previous screen and once on this one. Because let's visit a device here, and actually it's switch 1, and I've already got it on that info we need. And I've got that info highlighted because, of course, when we're troubleshooting, that's going to be the first thing we check. What's the status of the port? And we know the first part of that, fast Ethernet 01 is up, line protocol is up. The first half of that refers to the physical state of the interface, the second half to the logical state. And I probably tell you that too often, but the thing is, no one told me when I was studying for the CCNA what the line protocol even was. So now you know. And the thing is, we'll see some situations later where the line protocol might be down. But the reason I'm showing it to you now is that, we could have a duplex mismatch right here. And the thing is, the link would still be up and up, which is usually what we want. It would just be ineffective as far as transmission and receiving. So the thing is, you could go in here and say, well, okay, physically the interface is up. So we know, the cable is seated correctly. We know the interface is up. We know if we saw administratively down here, we would just need to open the port. Everything would be beautiful. Then if you have line protocol is down, that's a logical issue. That could be something where a clock rate is not set correctly. Again, something we will go over later. But it's some kind of logical issue. There's nothing physically affecting the line protocol. It's strictly logical. So now that I've hit you over the head with that, here's the problem with the duplex mismatch. This is what you're going to see when you have one. And you're just going to maybe get a vague report from somebody, well, it seemed a little slow, or all of a sudden, this isn't working right. And if you don't know what you're looking for, a duplex mismatch can be very, very difficult to spot. So that's why we want to avoid this situation at all costs. And there's really no reason to have that unless you hard code it. So again, the biggest problem with Autonegotiation is when it's running on one end, not running on the other. Then you're going to have a duplex mismatch. Otherwise, it's going to work so smoothly you're not even going to think about it. Speaking of interface names like Fast Ethernet 0/1 and that kind of thing, where do we get those names from? Why don't we just call them Fast Ethernet 1, Fast Ethernet 2, that kind of thing? Going to have that information for you along with a little more on console ports and some port descriptions. That's coming up next.